So I think we are live now. Okay, let's wait for YouTube to get everything in place. And I think we are live and good to go. Okay, hello everyone, and welcome to the stream. I hope you're doing all right. Um, and today we're going to be creating a multiplayer board game using fish networking. I'm particularly excited for this live stream because I love board games and I am currently working on a board game project for myself. So that's why I'm quite excited for this live stream. I'm going to cover things like turns, how do I manage turns in a board game, best practices for like synchronizing player turns and stuff like this, moving between tiles, etc. So I hope you will enjoy the live stream and let's get started. So right now, as I usually do, I have a simple scaffolding project here with fish networking installed, a couple of scenes, Text Mesh Pro, and yeah, that's actually pretty much it. Okay, so now I need to go in the file menu just to make sure, add my two scenes here, save the project, and continue. The first thing we need to do, as usual, is to create a new empty game object, and we're going to call it the network manager. Okay, now I'm going to add a network manager component. And I'm going to choose the default prefab objects as the spawnable prefabs. Okay. Afterwards, I'm going to create a simple UI management system real quick to allow us to switch between menus and stuff like this. And I've actually went into more detail on how to do UI management in a multiplayer game in a previous live stream. So I highly suggest you check out my channel and see what you can find there. And yeah, I hope you'll enjoy the content. Okay, so let's go ahead and continue, but actually give me 1 second, please. Yeah, forgot the overlay. Okay, now let's go ahead and begin the UI management system. So I'm going to create a new folder and call it scripts. Inside here, I'm going to create a couple of folders, player components, and pawn components. Okay, in the player components folder, I am going to right click and create a new player script. Okay, I'm going to open it in Visual Studio, and as I usually do, I'm going to go ahead and seal the class because I'm not going to be inheriting anything from it, so driving anything from it. I'm going to inherit the mono behavior class, and I'm going to remove all the default code. And inside the player class here, we're going to go ahead and add a singvar public string username just to identify the different players. Another one called is ready, and it's going to be a boolean. And finally, a singvar of type pawn. Okay, and we're going to call this one controlled pawn. Okay, let's go ahead and create this missing pawn class. So inside the pawn components folder, right click and choose create C# script and create a new class and call it pawn. Inside the pawn.cs class, we're going to seal it. We're going to inherit from the mono behavior. I'm going to remove the default code, and I'm going to add a singvar. I'm going to say public player controlling player. So this way, it's easy for the pawn to know who is controlling it and for the player to know which pawn is being controlled by him, so that we don't need to have to store references to objects all over the place. Okay. Now I'm going to remove the unnecessary namespaces. I'm going to go to my player class here, and I'm going to add a singleton reference to it. So public static player instance, and it's going to be a property. We're going to say get and private set, so we can only set it from inside this class. Going to override my onStart client method. Okay, and inside it, I'm going to say if not is owner, we simply exit the method. So if this object isn't owned by the connection, we simply return, and that's it. Then I'm going to go ahead and say instance equals this. Okay, as you can see now, we have this basic class here. So I'm going to remove the unnecessary namespaces, and I'm going to go in Unity, and it did compile, so that's good. What the heck? Give me a second. Had some mouse issue there, so excuse me. I'm going to now create a new folder. I'm going to call it UI. Inside the UI folder, I'm going to right click, create a new view class, which is going to be basically whatever view or UI panel we're going to display. Going to go ahead and mark this class as abstract. I'm going to keep it deriving from mono behavior only. I'm going to remove all this. I'm going to add a public bool is initialized get private set. Okay, and I'm going to add a public virtual void initialize, and inside this method I'm going to say is initialized equals true. Okay, this might seem a little overwhelming because I'm like writing it real quick, but as I said before, I have already explained this UI management system in more detail in a previous live stream, so I highly suggest you go and check that out. After or before you continue watching, that doesn't really matter. You're going to see how it works here as well. Okay, so we're now going to add a public virtual void show, and we're going to give it an object, parameter of type object, and call it args. I'm going to give it a default value of null, and inside here, so I'm going to say GameObject.setActive true. I'm going to add another method, public virtual void hide, and I'm going to disable the game object inside of it. I'm going to remove all the unnecessary code, go in Unity, right click, create a new class. I'm going to call it View Manager. Open it up in Visual Studio. I'm going to seal this class now, and we're going to remove all the default code. We're going to add a Singleton Reference, so public static View Manager instance, get private set, and I'm going to go ahead and inside the awake method, I'm going to assign this instance to the object. Okay, and now I'm going to add some serialized fields. So we have a message from Stefan429. Why you always stream so late? It's early in the morning, so my house is quiet, so I can stream without interruptions. So yeah, that might change in the future, but it's going to stay like this for the foreseeable future now. That's such a contradicting sentence, but anyways, let's continue. I'm going to add a serialized field of type view, and it's going to be an array. I'm going to call it views, and I'm going to add another one and call it serialized field. I'm going to call it view or default view. So it's like the default view that will show up when you start the game. And then I'm going to add a private non-serialized field of type view, and I'm going to call it current view. Okay, Now I'm going to go here and add a method. So public void initialize. And inside the initialize method, I'm going to go ahead and iterate over all my views. So views, okay. We got another message from Stephen. I always have to catch them on VOD, but you do you. Good night all. Okay, thanks for showing up, Stephen. I hope you will enjoy the video. Goodbye. Now inside our for each loop, I'm going to say view.initialize, okay, and I'm going to hide all the views by default. So we initialize them, then hide them if they aren't already hidden, okay. And down here, I'm going to say if default view is not equal to null, we say default view dot show. Okay, so we show the default view. Now I'm going to add a couple of static function methods here. So public void show. Excuse me. So our show method here is going to allow us to show different views, okay? And it's going to take a generic parameter of type tview, and we're going to give it an object parameter, and we're going to call it args. And then we're going to add a generic type constraint, say tview is a view. Basically what this line here means is that we have a generic method, okay, or a method that takes a generic parameter called tview, and this generic parameter must derive from view, okay? So if you try and supply any other class that doesn't derive from view, you're going to get a compile time error, okay? Now here, I'm going to simply say for each view inside my views array, and I'm going to check if view is of the type tview. So basically if the current view at this point is matches or derives from the type we supplied to this method, then we're simply going to say if current view is not equal to null, we say current view dot hide. So we hide the current view, and we say view dot show, and then assign the current view to the view it shows, okay? Then we simply break. And to reduce nesting, we're simply going to invert this here. So we're going to say is not view, so we continue. And otherwise we do this right here, okay? And that's pretty much it for the first show method. Now we're going to add another one that will allow us to show a specific view object. So public void show view, and just like we did before, we supplied an object parameter called args, and right here we're going to say if current view is not equal to null, then current view dot hide, okay? Then we show the view and supply the arguments, and we need to do the same here actually, okay? Then we're going to assign the view to the current view to the view we're trying to show. That's pretty much it for both show methods. Now let me just do a quick look over them to make sure I didn't screw anything up. So yeah, that's pretty much it. Now we have our view manager. Let's remove the unused namespaces. Let's close both of these classes here. Let's go back to Unity. It did compile, so that's good. I'm going to right click, create a new script, and we're going to call it multiplayer menu view. So this multiplayer menu view is going to be basically the menu where we can host or connect to a game. So let's go ahead and seal this class and inherit from view. Remove all the default code. And now I'm going to have a reference to a button that allows us to host, a button that allows us to connect, and finally a button that allows us to exit the game. So I'm going to go ahead and say serialize field, private button, host button, serialize field, private button, connect button, and finally serialize field, private button, exit button. Okay. Now that we have this, let's go ahead and override the initialize method. And you can see right here that I kept my base call because it's important. We have a message from Sean Chambers, which says, I was here. You indeed were. Okay, let's continue. Because as you can see inside our base call, we have we set our initialized boolean to true, and since it's private, it can be only set from inside the view class. You must call the initialize the base initialize method in order to fully initialize your view. Okay. Now let's go down here and say host button, one click, add listener. Inside here, we're going to say instance finder with server manager dot start connection, and instance finder dot client manager dot start connection. So basically, we're starting a server and the client at the same time, which allows us to basically host the game. Okay, now our connect button, we're going to say on click dot add listener, and we're going to say instance finder dot client manager dot start connection. Let's switch this to an expression body, and that's pretty much it. We just need to add the callback to the exit button. So I'm going to say exit button on click dot add listener application dot quit. So when we press the exit button, if we are in a player, it's going to exit quit the game. Now I'm going to remove all the unnecessary code and close this class, go into Unity, and begin our UI setup. As you saw, we need to have the view manager class in the scene. So I'm going to right click, create view manager. I'm going to move it as the second sibling, and I'm going to add the view manager class. Now here I'm going to create a canvas. Excuse me. So UI canvas. I'm going to change the scaling settings to something like this, as you can see here, so it scales correctly across different resolutions, taking into account the reference resolution that is 960 by 540. I'm going to right click and now create an empty object, and I'm going to call it multiplayer menu view. I'm going to make sure that it stretches across the entire screen. So I'm going to select the stretch on both axes, and I'm going to set all the offsets to 0. Okay. Now, if we focus on our object here, as you can see, it fills the entire screen. Now I'm going to right click UI and select button text mesh pro. This is going to be our host button. Then we need to tweak it a little bit. So we have 200 here and 50 here. Going to anchor it to the top right corner of the screen. Going to change the pivot to be 1, 1 on both axes. Then I'm going to change the offset to something like -10 and -10. So it sticks to the top right corner. Okay. I'm going to change the text here to be host, and I'm going to duplicate this button and move it down a little bit. I'm going to rename it to connect button. I'm going to change the text to connect, and finally I'm going to add a quit button or exit button, and I'm going to align this one to the bottom left corner of the screen, changing the pivot to be 0 on the x-axis and 0 on the y-axis. I'm going to change the offset to 10, 10. Okay, now we change the text to exit, and that's pretty much it. Now I'm going to select my main menu view here and add our main multiplayer menu view. Okay, there's one thing that we did miss. We need to go to our view manager class, double click on it, and go and add one more field. So this field is going to be a serialized field, private boolean auto initialize. Okay, and inside the start function here, I'm going to say if auto initialize, then initialize. Okay, so that we don't need any other object or class to initialize our view in case we need that. And here I'm going to change the default view.show to be the show method call and supply it the default view. Okay, now I'm going to go back to Unity, assign my multiplayer menu view to add it to the array here, and I'm going to set it as my default view. Okay, and we can go ahead and check the auto initialize checkbox here and save. Okay, and I'm going to go to my network manager and add a default scene component, give it our two scenes that we have here, so scene 1 and scene 2, and excuse me, I'm going to add a player spawner script component, and I'm going to create an empty prefab here, call it player. I'm going to reset the position, add the player component, and we have our player. Now let's go ahead and create a new folder, call it prefabs. Prefabs. I'm going to drag my player into the prefabs folder, and I'm going to delete its scene object. Now I'm going to go to my network manager, drag the player, and add it here. I'm going to uncheck add to default scene, and I'm going to leave the spawns empty. Okay, so far so good. Now I'm going to go ahead and enter play mode, and we get an error. Why is that? Let's see. Yeah, because we forgot to assign the buttons here. So assign the host, connect, and exit buttons. And I'm going to enter play mode again. Now, as you can see, no errors. And when I click host, I move to scene number 2. Great, and our player did actually spawn. Now I'm going to exit play mode and begin adding the basics relating to the board game. So basically, we need to first have some sort of lobby or a game manager that tracks the number of players and has a couple of methods and some properties that allow us to check whether we can start the game or not, whether there's enough players or not, and more. Okay, so in the scripts folder here, I'm going to create a new script and call it game manager. Okay, then I'm going to open it in Visual Studio. Let's go ahead and seal the class, and let's derive from network behavior. Excuse me, I had a slight interruption there. Okay, and I'm going to add a Singleton reference, so public static game manager instance get private set, and here we're going to go inside the awake method, and I'm going to set the instance to be equal to this. Okay, then I'm going to have a couple of fields here. Okay, the first one is we're going to have syncvar public boolean and start get and private set, and since this is a property, we need to add the field specifier or the field attribute specifier to our attribute here, so it targets the properties backing field. And then we're going to have a field syncvar public boolean did start. So this here checks whether we can start the game, and this here tells us whether we did start the game or not. And before all this, let's go ahead and add a new so public read-only sync list, which is a list that can be synchronized across the network of type player. And we're going to call it players. And let's actually make this a property. So here, make it a get only and initialize it in place. Then let's go here and say field sync var. Sync object. Okay, because any custom sync type like a sync list or sync dictionary, etc., even types that you create need to have the sync object attribute and not the sync var attribute. Okay. And now that we have this, let's go and add an update method. So we're going to check if not is server. So if the code isn't if this object isn't like executing on the server, then simply exit the method immediately. Okay. And then we're going to go down here and say can start equals players.count is more than 1. So if we have more than 1 player in our game, of course, a board game can be played in single player unless you have AI, then we cannot start the game. Okay. And now I'm going to add a couple of methods here. So public void start game, public void stop game, and I'm going to decorate both methods with the server attribute, so it warns us if we try to execute this code anywhere but the server. Inside my start game, I'm going to say did start equals to true, and inside my stop game method, I'm going to say did start to false. So far, so good. Now, you might ask, how do I track the players that join and disconnect? Pretty easy, actually. So go to your player class here, and let's override on server start, or on start server, sorry. And I'm going to say game manager dot instance dot players dot add this. So when the object has been started on the server or spawned on the server, or sorry, actually initialized on the server, we are going to add it to the game manager players array list actually, and let's override on stop server, and I'm going to say game manager dot instance dot players dot remove this. So when a player joins, it adds it, and when it leaves, it removes it. Pretty simple. Okay. Now let's go ahead and test this by first going into our game manager here, and I'm going to simply add a debug statement. So debug.log. There are players count players in the game, and I'm going to make this an interpolated string, and I'm going to go back to Unity. I'm going to save, and I'm going to do a quick build. So let's go ahead and do a clean build. I'm going to right click, create a new folder, and let's call it builds. Inside the builds folder, I'm going to say let's say debug, and I'm going to select this folder here. And it's not going to take too long to build, just a couple of seconds. Okay. And once it's done, we can go ahead and exit this. I'm going to go to my project settings, click on player, and I'm going to tweak some settings here. Let's go to resolution and presentation, change the full screen mode to windowed, and I'm going to say 960 by 540. Then set resizable window to true and save. Okay. Now I'm going to save my game, and I'm going to click Control B to do another build now. And then I'm going to enter play mode in the editor. And let me check something real quick. Yeah, we forgot to set this build as the debug build. So I'm going to do this real quick. development build, script debugging enabled, and let's save. Do another build. And yep, so allow access. Let's enter play mode here. Let's go ahead and attach the console to the player. And the first thing I'm going to do is host. Okay, we get an error. Oh yeah, because we actually forgot to add the game manager to our scene. So let's go to scene number 2, right click, create empty, and let's name our object game manager. Let's move it all the way to the top here. Let's reset all the transforms. Let's add the game manager component. You might not know this, but Fish networking supports scene network objects. Basically, you can have network objects present in the scene without having to spawn them at runtime, and they will be automatically initialized and be ready to use when you load the scene if you have a server active, okay? Now let's go to scene number 1. Let's save, Control B. Now our player is ready. Let's go ahead and attach the console to the player. Let's enter play mode. And let's host here. And as you can see, it's logging there are 0 players at first because, yeah, then we get 1 player in the game. Then, if I connect from here, you can see that a new client has connected, a new player has spawned, and we are getting there are 2 players in the game. So far, so good. We have the basics for the lobby. Now, let's go ahead and wait a couple of minutes here and see if there are any questions. If anyone has any question regarding anything that we have done so far, go ahead and ask it right now. Okay, let's wait a little bit more. So far, no questions, so I'm going to go ahead and continue on. Now, the next step in our multiplayer board game here is to have a board, of course, and what I like to call pawns or tokens, whatever, that we can use to move that are able to move on the board and be synchronized correctly. To do this, let's go ahead and go to scene number 2, and let's switch to the 3D view now. And I'm going to simply have my board as cubes. Or, you know what, cubes or quads. Just to have the feeling of depth, let's go ahead and do a cube, okay? I'm going to call it tile. I'm going to remove the box collider because we're not going to use it. And I'm going to reset the position for now. Then I'm going to actually create a new empty object, and I'm going to call it tile. Then I'm going to move this tile here to be a child and rename it to model. Then I'm going to stretch it to be 5 on the x-axis and 5 on the z-axis. Okay, and I am going to go ahead and create a prefab of it here, and I'm going to delete it from the scene for now. Then I'm going to right click and create a new empty object, and I'm going to call it board. So this is going to be our board, and it's going to consist of multiple tiles. In this case, I might just make it 5 by 5, so it's small, but it's, you know, good enough for our testing. I'm going to go ahead and add the tile. Then I'm going to make sure that the tiles are placed correctly. So let's go ahead and configure our grid snapping settings so they are big enough. Now let's move this to here. So -10, -10. And I'm going to rename it to tile 1. And actually, to automatically do this, let's go into our project settings editor. And I'm going to go scroll all the way down and change this to this. Game object naming. Switch it from this default horrible naming scheme and choose this one instead. whatever you prefer. I just prefer this because it suits my style. I'm going to go back to the scene view. I'm going to duplicate, move my tile forward, duplicate, move my tile forward, duplicate, move my, and so on. Okay. Now let me do this real quick. And make sure you're doing it around the board's origin. Like, make sure that the board object itself is at the middle of all the tiles. Okay. And my tile number 5 here, I'm going to move it. So, sorry, rotate it 90 degrees. So it points in this direction now. And I'm going to duplicate it. And let's see. 2, 3, yeah. Let's now rotate tile number 9. And let's rotate this tile again. Okay, now we have a basic looking board. I'm going to go ahead and create a new material. So create a new folder called materials. And inside it, let's create a new material and call it, for example, tile. And let's select our tile prefab. Let's give it the tile material. And I'm going to change this material to be maybe a slightly reddish or brownish color. Yeah, something like this. Yeah. Okay. Now that we have this and the material, let's remove this and make sure we have no highlighting or anything because this is supposed to be wood, you know. Okay, I'm going to mark my board as static and make sure to mark the children as well. Then save, select the tile object, and let's go ahead, no, sorry, select the first tile or any tile and apply all the overrides. What's interesting is all of these are still, yeah. Okay, now we have our tiles and we need to have positions for the pawns or the tokens on each tile. Let's select our tile prefab here. And as you can see, it has nothing. Now let's right click, create an empty and say pawn positions. Yep, and let's go ahead and move it. So since I'm testing and there is never going to be more than 2 players in my case here, the editor and the player, I'm simply going to have 2 positions, but you can have 4, 5, whatever you see fit for your game. I'm going to move this here, so change the snapping settings to 0.5, reset the position and move it to here maybe. Okay. Actually, let's duplicate this, and I'm going to call it position, pawn position, and pawn to position. Now let's move this one here, and this one here. So they are the opposite of each other, and they have distance between them. Now, if we save and go back to our scene, you'll see that all the tiles have the positions placed correctly without us having to go through each and every tile and do it ourselves, which is great. Now I'm going to go ahead and right click inside the scripts folder. I'm going to create a new folder and I'm going to call it, wait a second, where did that go? Okay, no problem. Right click, new folder, and I'm going to call it board components. And I'm going to first create the board class. Now we're going to seal the class, of course, and we're going to derive from network behavior. And we're going to remove these 2 here because they're not important. Then go back to Unity. And let's go ahead and add a new tile class. Okay, we're going to seal this class, and we're not going to make it a network object. We're going to simply have it as a normal network mono behavior, and we're going to remove the default code, and I'm going to remove these two here. Now let's go inside our port here, and we're going to add an array. So public tiles, and we're going to make it a private set. Then we're going to go ahead and say field, serialize field, so that it can be accessed from outside and edited in the inspector, but cannot be set from outside the board class. Okay, and let's go inside Unity now, select our tile prefab here, add the tile component, select our board object here, and add the board component. Now let's go ahead and right click and select properties, then select all the tiles in order and add them to our tiles array. Make sure they are in order, because otherwise there will be some very strange movement problems for the pawns and stuff. So make sure they are in correct order. Okay, now I'm going to save, and that's pretty much it for the board and the tiles. Now, going back, as I mentioned, we need to have, again, some kind of token or a pawn to move around, right? So what I'm going to do is, as I did at the beginning of the stream, have a pawn class here. And I'm going to have a sync var field here called controlling player, which is what player is actually controlling this pawn. Now, I'm going to add some methods. So the first one is going to be public void server move int tile index. Okay, so we're going to make a server RPC, and we're going to say require ownership equals to false, just because we might need to move it from the UI, and in that case it might not work because the UI doesn't own the pawn. So yeah, we're going to say require ownership equals to false. What this basically means is that you can call the server RPC from any client and it will go through. Okay, this is usually not a good idea because you might make it easier to cheat. But in our case, since this is not going to be a real game, I'm just going to use require ownership. Otherwise, you might want to use broadcasts or more sophisticated communication between the pawn and the player. Okay. Now that we have this method here, let's go ahead in Unity and actually right click and create an empty game object. I'm going to call it pawn. I'm going to reset the transform. I'm going to add the pawn component, and I'm going to add a network transform component. Make sure you add this so we can actually synchronize the position. And since we're going to be synchronizing the position and the rotation only of the pawn, or actually just the position, I'm going to disable the two other synchronizable properties. Okay, so make sure you are only synchronizing the position. And inside my pawn class here, I'm going to move it on one of the tiles so I can configure it better. Okay, I'm going to right click and add a 3D object. Let's make it a cylinder, for example, and let's move it up so it's actually placed correctly on top of the board. And I'm going to remove the capsule collider, and I'm going to call it model. And as you can see here, we have our pawn ready to go. Now I'm going to drag the pawn and create a new prefab out of it. Then let's delete this and save. Now, how do we spawn this object? I'm going to use addressables because they are much easier to use than having to manually reference everything and stuff like this. But you can also use resources, you can do referencing, whatever. But I usually just use addressables because they are more convenient and much more easy to use. Okay, and they allow you to have different pawns, characters, whatever. Now let's go to Window, Package Manager. Going to select Unity Registry here. Going to scroll down and select the addressables package. And I'm just going to wait a couple of seconds until it installs. So we have a question from Red Santilaces. I'm sorry, can't pronounce your name. What board game is this? It's just going to be a generic board game where you can move around, purchase tiles, and that's it. We're going to have income, of course, but it's going to be a simple one. This is meant to be a basic tutorial that will show you how to create the basics of a multiplayer board game, okay? You can use the base here, the base that we create here, and extend or build upon it to create whatever board game you would like to, okay? Hope this answers your question. Now we have the addressables installed, so I'm going to close this. I'm going to save my scene, and I'm going to select my pawn object, prefab, sorry, and as you can see, it did add a field here, called a check mark here called addressables. So let's click it, and I'm going to change the address here to be pawn. I'm going to save, and just to make sure that we don't get any errors when building, I'm going to go to Window, Asset Management, Addressables, and Groups. I'm going to select build here, and then I'm going to say clean build all. Okay, so it did create a clean build. Now we're going to select build, new build, default build script to actually build our addressables. This usually needs to be done once, and it will automatically be done for you afterwards. And sometimes you don't even need to do this because I just do this because sometimes Unity has some, quirks and bugs. So this is just to make sure you don't encounter them in the live stream. Now I'm going to save, and I'm going to open up my player script. Let's reload the Visual Studio solution. And now, remember the two methods that we added here, the start game and the stop game one? We need to add a methods called similar methods to each player so that we can, the players can be notified when the game has started and has stopped, okay? Now I'm going to go to my player script, and I'm going to add a public void start game. And another one, public void stop game. And I'm going to decorate them with the server attribute. So both of the two methods here are going to be called on the server, and if you try to call them on the client, we will get a warning, okay? So inside the start game method here, I'm going to go ahead and say game object pawn prefab equals addressables dot load asset async, and I'm going to supply the game object as the asset type parameter, and I'm going to give it our address, which in this case is simply pawn, and I'm going to say wait for completion. The wait for completion method here allows you to block the loading, so you can do it synchronously. If you want to do it asynchronously, you can do, but I highly recommend, especially when doing networking and stuff like this, if you can make everything sync, so it's easier to manage and has less side effects and less errors, okay? Now that we loaded our prefab, I'm going to say game object pawn instance equals addressables, instantiate pawn prefab, okay? Then I'm going to spawn my pawn instance, and I'm going to supply the owner property as the owner connection to the spawn method. What this does right here is we spawn the game object of the pawn on the server, and we assign the ownership of this connection, or the connection that's calling the method, the spawn method, which is in this case the owner, to the to actually own the pawn instance. Okay, so basically you spawn an object, a network object that's owned by you. Okay, you can of course spawn objects that's owned by other connections, but in this case we don't need to do that. Okay, so supply owner. Now that we did this, let's go ahead and say let's actually do it before and say pawn controlled pawn equals pawn instance dot get component pawn. So we assign the pawn we just spawned to our sync var here. Now I'm going to say controlled pawn dot controlling player equals this. So after we assign our pawn, we assign ourselves to the pawn, so it knows that we are controlling it. Now inside the stop game method, I'm going to do an if controlled pawn is not equal to null, so controlled pawn dot despawn. Okay, so when we stop the game, I would like to despawn my pawn object. Okay, so that's pretty much it. Now let's save, and I'm going to enter Unity now, and I'm going to go to scene 1. I'm going to do a quick build. Okay. And this time, just to confirm that everything is 100% working on both the client and the server, I'm going to select the console to clear it and connect it to the player. And I'm going to enter play mode. And this time I'm going to host inside the player. So I'm going to click host here. And I'm going to connect from inside the editor. Now, as you can see, there are 2 players in the game, which is correct. Now I'm going to go to scene number 2, and I'm going to select my player, and we don't get, oh yeah, because we actually forgot to call the method. Now let's exit play mode here, and let's actually do that. So let's add a lobby view, so it displays the players in the game. So let's go to our UI folder here, right click, create C# script. I'm going to say lobby view. Once it's created, let's seal the class. And let's derive or inherit from the view class we created earlier. Let's remove all the code. And now we would like to have a text Mesh Pro reference that allows us to display the players that are connected. A button that allows us to toggle our ready state, so whether we are ready or not. And finally, a button that's only visible on the server that allows us to start the game when everyone is ready. Okay. Before we do this, let's go to our player and let's go all the way up. And let's go ahead and add a, no, let's actually add it down here. Where here. So public void server set is ready. I'm going to set this to be a boolean. I'm going to put value, and I'm going to decorate it with the server RPC attribute and say require ownership equals to false. And inside the method here, I'm going to say is ready equals value. Okay, this might be too verbose for some people, so a very good way to do this is actually to remove this. Okay, go to our field here and turn it into a property which has a get method and a set method, accessors. And I'm going to add the field specifier, and I'm going to decorate the set accessor with the server RPC attribute and say require ownership equals to false. Okay, let's of course change the name to is ready. Now that we have this in place, let's go to our lobby, and I'm going to begin adding the stuff we talked about earlier. First one of them being a text mesh pro text, and we're going to call it players player list, and then we're going to have a serialized field private button ready button, and I'm going to have a serialize field private button start button. Okay, let's go down here and override the initialize method. And inside the initialize method, I'm going to say ready button dot on click dot add listener. And if you remember here, we have a singleton reference to our player that's assigned on start client. Okay, but how do we make sure that the player exists before the UI is initialized? Okay, since we have this field here and we can have multiple view managers, yeah, and we can have multiple view managers, we are going to have a different view manager in the gameplay scene, which is scene number 2, and we're going to disable auto initialization, and we're going to do this and initialize it inside our player class. So I'm going to say view manager dot instance dot initialize. Okay, and I will show you the configuration steps as well. So that this way we first assign our player singleton and then initialize the UI, and only initialize the UI for the local player so that we don't get any conflicts or incorrect data being displayed. Now I'm going to go back to my lobby view and I'm going to say player dot instance dot is ready equals not player instance dot is ready. So basically, if we are ready, then unready, or if we are not ready, set our state to ready. Okay. Now I'm going to go to the start button and say dot on click dot add listener player game manager dot instance dot start game. And actually, before we do this, let's go ahead and add if instance finder dot is server. Let's move this code inside. So we check if we are currently running on the server, okay, then initialize the start button, and otherwise disable the start button. Okay, so everything is good so far. Let's go and add an update method, and I'm going to check if not is initialized. So if our view hasn't yet initialized, we return. Okay, and I'm going to go down here and I'm going to say start button dot interactable equals, so whether we can start the game or not, equals game manager dot instance dot can start. Okay, this here line we don't need to add an servo check because it's going to be already disabled if we start on a client, so this is okay. You can add an servo check, but this is just a waste of performance. Okay, now I'm going to go ahead and iterate over all of our players and construct a string containing their names or their IDs and their ready state. Okay, so we're going to say string player info, or let's say players equals, and this is a terrible name, I must come up with a good name. I'm going to say info, okay, equals an empty string, okay, and I'm going to say for I is less than game manager dot instance players dot count, and then we go here and say player equals game manager dot instance dot players I, and I'm going to supply info, so let's say plus equal, make this an interpolated string, and I'm going to say player plus the player's client ID, so ID, yeah, owner ID, okay, and I'm going to say is ready player dot is ready, okay, and finally down here I'm going to say player list dot text equals info. Let's actually rename this to player list like this, so it's a better name. And yeah, that's pretty much it for our lobby. Now let's remove these two namespaces here, save, and go back to Unity. I'm going to go to scene number 2. I'm going to create a new view manager. So we're going to call it view manager. I'm going to move it underneath the game view, game manager, and I'm going to reset the transform. I'm going to add the view manager component, and this time I'm going to leave auto initialize unchecked. Okay, make sure this is the case, otherwise you'll get very nasty bugs. Okay, now I'm going to right click and create a new canvas, and I'm going to configure it like I did the other one. So change the UI scale mode to scale with screen size, set the reference resolution to 960 by 540. By the way, this can be any resolution, any reference resolution you would like to target. This resolution right here is a widescreen resolution, or a 16:9 aspect ratio. You can, of course, support different resolutions, but yeah, this is the one I'm going to use. And the match slider here, when creating games that are going to be played in landscape, make sure to match the height when scaling, okay? So that, of course, when the height changes, the UI will scale down, okay? And sorry, when the size of the screen decreases, or the height of the screen decreases, the UI size will be reduced, and when it increases, it will be increased. And vice versa when making portrait games, or games that will be played in portrait mode, make sure to set the match to the width, so that when the width of the screen changes, the entire UI will change the scale. This will give you very good results usually, and it saves you a lot of headache when making complex UIs, and don't have to take or create different layouts for each and every resolution. Okay, let's go ahead and continue now. I'm going to right click on our canvas, create an empty object. I'm going to call it lobby view. I'm going to make sure that it fills the entire screen, and I'm going to add my lobby view. Now I'm going to focus on it and go into the 2D mode. I'm going to right click UI text mesh pro text. I'm going to say this player list, and I'm going to anchor it to the top left corner of the screen. So 10, so it's anchored here. I'm going to increase the size a little bit, so it's 300 by maybe, let's see, we might have 2 lines, so yeah, let's say 100. Yeah, let's make it a square, so it's 300 by 300. And I'm going to add just a temporary string. Let's say player 0 is ready bolts. Okay, so the width isn't enough. Let's increase it to 350. Let's make it 500 or 400. Oh, 400. Let's actually reduce the font size and set the minimum to something like 9 and the maximum to something like 24. Yeah. And let's make sure we disable wrapping, so we are going to have lines that don't wrap, okay, even if they're long. And that's pretty much it. Yeah. I'm going to right click now, create a button. I'm going to call it ready button. Okay. It's going to be anchored to the top left, top right corner of the screen. So -10 and -10. And I'm going to change this to ready. Okay. Then I'm going to duplicate this button, and I'm going to call it start button. Change the text to start. And actually, in order to make it easier for the player to know whether he's ready or not, I'm going to go in my Visual Studio here. I'm going to add another reference to the text that's inside the ready button. So private tmp text ready button text. Okay. I'm going to go in my update method here, and I'm going to make sure that when the player is ready, we change the color of the text from maybe red to green, okay, and vice versa. So I'm going to say ready button text dot color equals player dot instance dot is ready. So color dot green, otherwise color dot red. This is what's called a ternary operator. Basically, it's an inline if statement. So here we are checking if the player is ready. If the player is ready, then set the text color to green. If the player is not ready, then set the text color to red. Let's go into Unity, and now let's assign our references. So the player list, the ready button text, and finally the start button. Now everything is good. Let's go to the view manager, assign our lobby view as the default view, and make sure to add it to the views array. Okay. Now when we go to scene number 1, I'm going to go ahead and do a quick build. Okay, I'm going to enter play mode here. Then I'm going to connect the console to the player, and again I'm going to host in the player. Okay, and I'm going to connect in the editor. Okay, and as you can see, we have an array of a multi-line string here, and that says player 0 and player 1. Player 0 is here. So when I go ahead and click ready, you can see that it synchronizes the text correctly. And let's go ahead and click ready here as well. And when I click start, let's go ahead and see our game manager. Oh, we forgot to call the spawn method on the players. Sorry. Let's go inside Visual Studio, go to the game manager, and let's serialize these fields here so you can actually see them. Okay, then inside my start game method here, I'm going to do a for loop and iterate all over my players. So players.count, we're going to say players I.start game. Okay, and inside the stop game method, I'm going to iterate over all the players again, and I'm going to call the stop game method on each and every player. Okay, now let's save the game and let's go into Unity. Let's close this player here and let's do a quick build. Okay, I'm going to enter the play mode here. I'm going to connect, excuse me, the console to the player. I'm going to host in the player, and I'm going to connect in the editor as a client. So I'm going to ready on both, and then I'm going to click start. We got an error, okay, which is fine, no problem. Let's see just whether we, as you can see here, we clicked on did start is set to true, and can start is true as well because we have 2 players. Okay, so far so good, just this error is a problem. So let's see. Yeah, so we have a little issue here. Maybe we didn't add the player to the default prefab collection. So let's make sure we did this real quick. And everything is here. let's test this in the editor, make sure that we don't have any issues. Oh, wait a second, let's close the player. And let me go ahead and host. So ready, can't start because we don't have 2 players. So let's fix this. Let's go here and comment this line out real quick. Let's actually change it to players.all player is ready. So this basically is going to change the condition to be true. So can start is going to be true when all the players are ready. Okay, just for testing. Let's save, enter play mode. I'm going to click host, ready, and then I'm going to click start. And as you can see, we spawned a pawn object, and it references the player that spawned it, and the player references it as well, and everything is fine. So I'm pretty sure this is because of the addressables issue I mentioned earlier. So I'm going to go ahead and do a new build. And let's make sure that we have the setting. I think this there should be a setting here that allows us to automatically build addressables. It is already present, but I just can't find it right now. So let's go ahead and Control B. Okay. I'm going to connect the console to the player. I'm going to enter play mode here. I'm going to host and the player, then connect. I'm going to clear this, and then I'm going to click ready, and then ready here. Then I'm going to click start. We get an error, so spawn object has an invalid prefab ID. That's very interesting. So let's exit both of these here. And let's see. How do we have an invalid prefab ID? That's very weird. Let's see if we are actually loading the correct prefab. So we are indeed spawning the correct prefab. Interesting. So just to avoid this issue for now, I'm going to use asset references. So I'm going to say serialize sealed private pawn prefab. Okay, I'm going to remove this line here. Mark this as pawn. I'm going to move this to be pawn instance, and I'm going to say pawn instance dot game object. Okay. Let's save, and I'm going to go to my player and assign the pawn prefab here. Okay. Now I'm going to enter play mode real quick. Host, ready, and start. And everything spawns correctly. Okay. Now let's go ahead and do a quick build. Okay. Now let's connect the the console to the player. And as I did before, I'm going to host here and do a client from the editor. Then I'm going to click start. Yep. And as you can see, everything starts correctly. Now I have 2 players. Each have a reference to the correct pawn instance, as you can see. And each pawn instance references the correct player that owns it. Now, but we have a problem here. You can see that both of them spawn at the same position, which is not really what we want. We'd like to spawn each pawn in the corresponding pawn position, depending on the player that owns it. owns it, okay? That's easy. Let's exit the play mode and exit the player. Let's go ahead and select our port class here and open it up. I'm going to add a public static port instance reference. It's going to be singleton, so it's going to be settable only from inside the class. Inside our awake method, we're going to assign the instance to this, okay? And I'm going to go to my player, and I'm going to spawn the pawn at the position depending on its index. How do we do this? Basically, sorry, I had an interruption there. I'm going to go ahead and say int player index equals game manager dot instance dot players dot index of this. So we grab our own index, okay? Then we go ahead and choose here. So we're going to say transform spawn point equals board dot instance dot tiles 0. Of course, the tile at the index number 0 is going to be the starting tile. And then we're going to say dot find. Sorry, let's go ahead and actually add a reference to the positions. So tile, we're going to have a field, serialized field, public, transform pawn positions, so we can access it from other scripts. And we're going to say pawn positions player index dot, yeah. Okay, and as you can see, we grab the reference. Oh, we have a message from Wiglord. Oh, always late myself too, but I'm looking forward to replay. Oh, thank you for showing up, Wiglord. I appreciate you showing up. It's always nice to see you. And yeah, it's good to know that people watch the streams after the end. You have missed a lot, but I assure you that you will find the replay very interesting, I hope. So thank you. Now let's continue. We're going to say instantiate pawn prefab as pawn point dot position and quaternion dot identity. Okay, so far so good. Now let's save and make sure everything is set. Yep. Go in the editor. Select our tile here. Open it up and then select the pawn positions here and assign to transforms we have. Okay, easy. Now let's save and click Ctrl B to do a quick build. Okay, now we have the player. Let's connect the console and let's enter play mode and let's host in the player and connect from the editor. Okay, now I'm going to start, and as you can see, the player 1 has the pawn number 1 spawn at the correct position, and player 2 has the pawn number 2 spawn at the correct position. This is absolutely great. Now let's go ahead and exit the play mode here and exit the player here. And now let's add the most important component, that is the movement of the pawns or tokens. And this is going to be accomplished by using coroutines on the server and UI to choose which tile to move to. So we're going to use the UI to have something like a dice or a buttons that allows us to move forwards or backwards. So let's go ahead and implement this. Let's clear the console. And let's go ahead and select our pawn component here. Okay. Inside the server move method, we're going to have a call to start moving routine here, which we need to implement. So we're going to have private enumerator start moving, or let's actually just call it move and give it the int as the tile index. Okay, original value. Yeah, we'll get back to this right now. We're going to call move tile index, but we just can't call it like this. We're going to say start coroutine move and give it the I enumerator. Okay. Now inside here, we'll need a way to first find the tile position, the correct tile position, or the correct ending position, and all the tiles in between the current tile and the tile we would like to move to. In order to do this, I have came up with a couple of formulas and a couple of a function and a formula that, let's go in the editor so I can demonstrate it better in scene number 2. Assume we are standing on tile number 1 here, and I would like to, as you can see, this is the forward direction. Assume I would like to move backwards a tile, you know, so that I can, for example, move this way. Oh, sorry. Move this way instead of this way without getting any errors or index out of range exceptions. How do we do this? You might say we use the modulus operator, but this is not the case. You need a little formula like this one here. Let's copy it inside visuals. And I actually came up with this one, so it's not just copy and paste code, okay? That was the worst laugh ever, but let's go ahead and continue. I'm going to say public void. Okay, let's remove this. And let's remove this because we're going to do an extension method. Okay, I'm going to say tiles.length. Tiles.length. Okay, you might look at this and say, what the heck is this? So basically, this allows us to index arrays in a negative, like by negative indices and not get errors. That's the first thing. And if we supply a number that's larger than the length of the array, it will wrap around correctly and return the correct tile index. Okay, so I'm going to zoom in a little bit so you can see this formula better. As you can see it here. Okay. Now I'm going to zoom back out and I'm going to continue. Now this returns the correct index. Now we would like to return the set of tiles in between the starting and ending position. How do we do this? Well, I have this this method here handy. Okay, so I'm going to copy it and I'm going to paste it right here. I'm going to remove this and remove this. Okay, so let's go ahead and remove these extra lines here. And what this enumerate slices method does is it simply returns all the tiles in between the start and end indexes, even if the start or the end are negative or positive or larger than the length of the tiles array. So it's like we can say it a safe way of retrieving tiles, okay? Or a range of tiles. Now I'm going to go ahead and change the return type to be tile, like this. And I'm going to remove the generic type parameter here as well. And here. Okay. And I'm going to remove this. So I'm going to say return array.empty. Okay. I'm going to change this to tiles. Here as well, it's going to be tiles. And we're going to call wrap. And tiles and ramp. Okay, let's see. Yeah, what the heck, what's an iterator? Let's go ahead and remove the name. Interesting. This is not an oh yeah, because we're using these here. so it's mistaking it for an iterator. Okay. Now we need to go ahead and add the values that we have here to the array that we would like to return. Okay, so I'm going to go ahead and say list tiles equals new tile list, and here I'm going to say tiles.add. Let's actually rename this so it's less confusing. Let's call it tile range or tile slice. Okay, and I'm going to go ahead and say tile slice dot add. Wait a second. So yeah, tile slice dot add tiles dot, yeah, as you can see here. Then at the end, I'm going to say return tiles slice dot to array. Let's just rename this to slice because it's very disgusting when it has the tiles name in it. I just hate it. And let's remove the, because we're using the newer version of Unity, we can simply use target typed new expressions, which save you a lot of typing. Okay, and yeah, that's pretty much it for the two methods we're going to use when moving the tokens. Okay, going to go back to my pawn class now, and I'm going to add a new singvar here. So I'm going to say singvar public int current position. Okay, and I'm going to go ahead down here, and then I'm going to get all the tiles between the starting, so the current and the end position. Okay, so we might actually change this as well to be the number of steps we would like to move instead of the exact tile index, so it's easier. So I'm going to call this steps and this steps as well. And here I'm going to say tiles equals board instance dot tiles, dot slice. We're going to say current position and current position plus steps. Okay, so now we have a slice of tiles that we would like to move on. Okay, and I'm going to iterate over all of them. Okay, and while we are moving, as long as the distance between the pawn and the ending position is more than a specific threshold, then we keep moving towards it. Okay, so now I'm going to say for each, for I is less than tiles, or actually, since this is an array, let's use a for each loop since it's not going to change. Tile in tiles. Okay, I'm going to say if transform dot position is not equal to tile dot position, dot transform dot position, we say transform dot position equals vector3 dot move towards, vector3 dot move towards tile that transform the position. No, we say transform the position, tile that transform the position, and maybe we need to have a speed variable. So let's go ahead and assign it here. So singvar public float. Let's actually make this private, and it's not. We don't need it to be a singvar. Serialize field private float movement speed. Okay, I am going to go ahead and assign it here. So movement speed times time dot delta time. Okay, and let's actually cache the position of the tile. So vector3 tile position equals tile that transform the position. Let's do the same here. And that's it, okay? Wait a second. We need to, this is not going to work as expected, because we need to select a tile, and while we are not at this current tile's position, we don't want to progress forward, okay, until we we actually reach the tile before. So I think instead of having to write all that code manually, I think I'm going to use DoTween. DoTween is a free tweening plugin available in the asset store here. I'm going to show it to you. There are two versions, the Pro version and the free version. Both of them have almost the same features. The Pro one has some extra niceties, okay? So I suggest that you use the free version, okay? Or really any tweening solution you would like to, okay? So let's go ahead inside Unity. Open up the package manager and go to my assets. Search for DoTween. I'm going to use the free version. And I'm going to import it. Okay, once it has been installed, let's clear the console and let's go ahead and fix this error so we can actually install the plugin. I'm going to add a yield break here just to remove the error. Yeah, and once you import DoTween, you will see this panel pop up. Let's click Open DoTween. Let's set it up. Okay, in my case, I am not going to be using the 2D physics 2D module or the physics module or the sprites module. I'm going to simply have these disabled, okay? And let's apply. Now let's clear the console. Let's go to preferences and let's go ahead and say recycle tweens to true, autoplay to none, and the ease by default is going to be in and out sign, so in out sign, as you can see. And yeah, that's pretty much it. Now let's go ahead and close this window, go back to Visual Studio now, and we can simplify this code here by removing this call here. So I'm going to say tile array tiles equals board.instance.slice current position and current position plus steps, okay? Then I'm going to go ahead and say vector3 path equals tiles.select. Select is a link method, extension method that allows you to perform a query on a collection and retrieve a certain value from it, okay? Basically, if you would like to extract something from a collection of a certain type, you can use the select extension method, okay, which saves you a bunch of lines, having tried it using loops and stuff like this. Of course, it has a very tiny performance penalty. It might be a big penalty depending on the size of the collection, but I'm going to use it just for the sake of convenience and to make this code a little bit more concise. So I'm going to say select tile and then say tile.transform.position. Not actually this, I'm going to go up here and say int controlling player index. We're going to say game manager dot instance dot players dot index of controlling player. Then here I'm going to say dot pawn positions controlling player index dot position. Okay, then I'm going to say dot to array, which so far this is easy. Now I'm going to go down here and then say transform dot DoTween, sorry, do path, and supply the path here that we created and give it a duration. So I might give it a duration of like 2 seconds. Then I'm going to call play. Okay, so far so good. Now we can remove this code here. change the movement speed so we can remove it. Actually, it's not useful anymore. And then I'm going to add a server-side variable or field. We're going to call it private bool is moving. And whenever we call the server move function, we're going to set it to is moving equals to true. And before that, let's check and say if is moving, then return, don't do anything. And here we're going to add a callback to our tween. So we're going to say that onComplete set is moving to false. Okay. As you can see, we first create the tween, add the onComplete callback, set is moving to false, and then play the tween. Okay. Now I'm going to save this. All right. Then I'm going to go back into Unity, and I'm going to create a new UI which allows our player to move the pawn around. So I'm going to right click, create a main view. Okay, now I'm going to enter the main view, and just like we did before, I'm going to seal this class, derive or inherit from view, remove the default code, and I'm going to add a couple of buttons. A button that allows us to move forwards by one tile, another one that allows us to move backwards, and yeah, that's pretty much it. So let's add serialize field, private button, move forward button, and serialize field, private button, move backward button. Okay, let's go ahead and override the initialize method. So I'm going to say move forward, not unclick, not add listener. I'm going to say player dot instance dot server move. Oh yeah, we forgot to expose this. Oh, well, sorry. Dot instance dot controlled pawn dot move. Okay, and let's say we would like to move a single step forward. Okay. Oh, let's keep this and change this to -1. Copy and paste our code so we have a forward here and backward here. Let's make sure that the two values are correct, and that's pretty much it. Okay, let's go and enter Unity again. Let's go ahead to our canvas. Let's right click, create an empty object, and we're going to say main view. Okay, let's fill the entire screen. Add the main view component. Switch to game view so we can see the UI. Switch to the 2D mode here so we can customize the UI better. I'm going to right click, select button, say move forward button, and I'm going to anchor this to the bottom right corner. So say 1 and 0, -10 and 10. Okay. So let's say move forward, duplicate this one, and say move backward. We're going to anchor it to the bottom left. Okay, so we're going to say this done, change the text. Okay, and I'm going to go in the main view, and I'm going to assign the references. Okay, I'm going to go to my view manager. I'm going to add the main view, but I'm not going to set it as the main view, as the default view, sorry. Then I'm going to disable both these objects, because by the way, the UI system allows you to initialize objects even if they are disabled. So enable them or disable them, it doesn't matter, okay, depending on your needs. Now let's go ahead and actually let's real quick fix the annoying string formatting here. I'm going to say if I is more than, let's see, let's go here and say int player count equals game manager.instance players.count. Let's say here player count is more than player count -1. Okay. And then we're going to say, sorry, actually less than player count -1. We're going to say player list text plus equal a carriage return line feed. Okay. So we only add a new line only when the index isn't the last one. Okay. Then I'm going to go to my player, and inside my start game, I'm going to use what's called a target RPC in order to display the main view only for my player. Okay. So I'm going to go ahead here and have a target RPC private void target start game. Okay. Supply the network connection. And I'm going to go ahead and say view manager dot instance dot show the main view. So this way, when we start the game and after we spawn our pawn, we're going to call the target RPC and supply owner as the target connection so that it displays the main view when we do start the game. Okay. Now let's go back in Unity. I'm going to make sure everything is properly assigned. Okay, let's go to scene number 1. Let's do, oh, actually, before we build, select your pawn, since as you can see here, we're moving the object on the server, and we have the authority here as client authoritative. This is good if you are trying to move the object from the client side, but in our case, we're moving it from the server side. So I'm going to uncheck client authoritative, and I'm going to keep send to owner checked. Okay, so let's save, and let's go ahead and do a quick build. Okay, let's enter play mode. I'm going to host in the player, and I'm going to connect from the editor. Okay, now if we start the game, you will see that we switch to the main view, and I'm going to go ahead and switch out of the main view. Now this pawn here is the editor's pawn. Okay, so when I click move forward, you will see that it moves forward, and when I click move forward here, you will see that the other one moves forward. Now let's actually keep moving here. Whoa, yeah. Excuse me, this is a bug because we do not actually set the value of the current position. So after we do move here, I'm going to go ahead and switch this to a block. Let's actually say, so tween equals this. I'm going to remove that, and I'm going to go ahead and organize the code a little bit. Let's say tween incomplete. I know you can chain them, but I like to make my code more self-explanatory. Okay, and then I'm going to say current position equals current position plus steps. Okay, yeah, use component assignment. What the heck I was thinking. Okay, then I'm going to say tween dot play. Okay, now I'm going to save, and actually let's reduce the movement time, so like 1.25 seconds. Save and go back to Unity. Okay, I'm going to do a quick build. Okay, then I'm going to enter play mode here, connect my console, host the game in the player, connect from the editor, click ready on both instances, and then start the game. Now, if I click move here, you'll see that the object moves correctly. And as you can see, it's synchronized. And when we reach a corner like this, you can see that it moves and rotates around correctly. Now let's test moving backwards. So as you know, this index here is 0, okay? So the index behind it is -1. So if we move backward, you'll see that it moves correctly. But because the rotation is set incorrectly, it moves here. So let's see. But it does move backwards correctly. Let's see if we move forward. Yep, it does move in the correct direction. Okay, now let's see here. Does it synchronize? Let's move backwards again. As you can see, it does indeed synchronize correctly. So this is great. Now let's see, by the way, the movement here, you can use a random value, so to simulate a dice, or you know, use whatever value you'd like to move to. You can use maybe have power-ups or stuff like this that allow you to move a double move, whatever. You can customize this to whatever you like. And as you saw, it's a pretty simple code. And I'm going to make sure to include a couple of methods that we use here in the project when I am going to publish it online, okay? Now, what's the most significant feature of board games is turns. Currently, we don't have turns. Any player can play at any time. Now, this is going to be the final part of the stream, so let's go ahead and implement turns, okay? There are other features that could have been implemented, like tile purchasing. We'll see if we can implement it before we run out of time, but yeah, let's go ahead and do what we can. So the first thing here is I'm going to go ahead and add a new variable, sorry, property. Excuse me. Field, I'm going to say serialized field, singvar. So public int turn get and private set. So this corresponds to the current player turn, okay? And I am going to go down here and then have a public void. Oh, not here actually. Let's see. Yeah, we're going to have two new methods. So public void begin. Actually, let's go ahead and say progress game. Okay, and we're going to decorate it with the server attribute. And we're going to say now, the first thing we're going to do is supply it an integer. So it's the current turn. So current turn, okay. And we're going to say for I is less than players not count. And we're going to say if I equals current turn, then we're going to say players. We're going to say have a player here, so player equal players I. We say player dot turn started, or let's actually make it so begin turn. Otherwise, we're going to say else player dot. You know what? We could actually unify this by having it as a single method call. So let's go here and have. Let's remove this, and let's rename this function to be more appropriate. Begin turn. Okay. And we're going to say players I dot begin turn. Okay. And let's go to our player class and implement the public void begin turn. Okay. And it's going to be called on the server, of course. So we decorate it with the server attribute. Okay. And inside the begin turn, we're going to do two things. First, check if the current turn corresponds to our player index, then we go ahead and enable the main view. Otherwise, we go ahead and show a view or show a message that tells us to wait until our turn comes. Okay. So before we do this, let's go to the game manager again and add another method. Yeah. I'm going to call it server public void end turn. Okay. This right here, we need to make it a server RPC so that the clients can actually send it. So we're going to have server end turn. And when we do this, let's go ahead and say turn plus plus, or actually turn equals turn turn plus 1 module by the players not count. So basically this is going to increment the turn count by 1, and if it exceeds the length of the players, okay, the player count, it's going to reset to the 0, okay, or otherwise this value wraps around. Okay, so if it's more than the players that count, it goes back to 0, otherwise it continues incrementing. Okay, and then we simply call begin turn after we increment the turn counter. Let's go to the, and let's change this to require ownership equals to false, so anyone can call it. Let's go to our player here, and once we begin the turn, I'm going to say target begin turn, and it's going to be a target RPC, of course. So let's create it. So target RPC private void target begin turn. Okay, and I'm going to go ahead and see, we need to supply this with a boolean, which basically checks is my turn. Let's actually call this, so is my turn, so is player turn, yeah, or yeah, no, let's see it, can play, yeah, so who can play. Okay, I'm going to go here and say if can play, then the view manager is going to show the main view, which allows us to move forwards and backwards. Otherwise, we're going to say, let's see, view manager dot instance dot show wait view. Okay, so we're going to create a new script and we're going to call it wait view. This view is going to be displayed for the players that cannot play yet. Okay, and here we're going to check and we're going to say game manager dot instance dot turn equals game manager dot instance dot players dot index of this. So if the current turn equals the corresponds to the player's index in the players list, then the player can actually play. Okay, let's go ahead inside our let's see, where is it? Yeah, the pawn here. And once we do finish moving, let's go ahead and actually call game manager instance dot end turn. Okay, and yeah, since this is going to be called from the server side here, let's go ahead and remove this. So let's rename it to simply end turn and remove the server at server RPC and change it back to server. Okay, since it's going to be already called on the server here. And let's see, what else do we need to do? Yeah, we need to create the waiting view. So let's go ahead, right click inside the UI folder, create a new wait view. It's going to simply be a an empty view class that simply displays a message and has no logic at all. Okay, so save, and let's go back to the editor. Let's go to scene number 2, go to our canvas, right click, say create and weight, name our new object weight view. You could fill the entire screen. Add the weight view component. Okay. Select the view manager, add the weight view to the views array. Okay. And inside the weighting view, we're going to right click and add a text. So let's go, yeah, let's leave it called text, and let's change the content to be, please wait for, let's actually waiting for other player to finish. And let's increase the size of this text, center it, and move it to the top of the screen. Oh, wait a second. 2D, let's go 1, and we get some -10, yeah, -10. Yeah, let's go and change this to have auto size and reduce the minimum to 9 and the maximum to 24. Change the color to something like green. Okay. And that's pretty much it. Okay, yeah. I'm going to, what did we miss? Did we miss anything so far? Nope, as far as I can see here. Yeah. So let's go to scene number 1, and let's go ahead and Control B to build. All right, let's enter play mode here. Connect our console to the player. Go to the player and host. Now I'm going to connect here. Let's go ahead and start the game. And as you can see, this is a bug, of course, since both players just initially start with the main view displayed. But if we move, you'll see that it actually switches correctly. So let's go ahead and fix this bug here. Let's go to the player. Okay. And we're going to remove this RPC call here. Okay. And let's go to the game manager, and let's go down here inside the start game, and we're going to say begin turn. All right. So when the game manager starts, begin the turn and display the correct views. Okay. Now let's remove the unused code here, and let's go to the editor. Let's do a quick build. All right, let's enter the play mode. Connect the console to the player. Host a game in our player. Connect from the editor. And let's start the game. All right, as you can see, the player here is waiting for this player to finish moving, to finish playing. So let's focus on the pawns here. And when I move here, as you can see, it switches to the other player, and other player will be able to play. As you can see, it's alternating between turns. Of course, you can have any logic in between. You don't necessarily have to immediately end the turn. You can simply display another view. You can add some special events, so when the player steps on a specific tile, he has the option to maybe move extra moves and pay money, something like this, you know? You can do whatever you want. Now, I think we have enough time to implement tile purchasing. Maybe, I'm not sure, but we will try. Okay, so of course, in tile games, in board games like this, you will have sometimes the ability to purchase tiles or, you know, own tiles in order to build stuff on it and add some extra things like maybe text players that step on it, maybe move like freeze players that step on a specific tile, and yeah, all sorts of crazy stuff. Now let's go ahead and implement the basic tile purchasing mechanic. Okay, so the first thing we need to do is go to our tile here, and since it's a mono behavior, I'm simply going to add a reference to field serialize field. Sorry, since it's going to be public, let's just go ahead and say public player owning player. Okay, so this is going to correspond to the player that owns it. And here I'm going to show you how to actually synchronize non-sync vars, okay, and synchronize data on mono behaviors like this, okay. Since our board is a network behavior, it can send and receive RPCs, okay. We're going to use something called observer RPCs, which are RPCs that are sent to all the clients, okay, in combination with a server RPC. All right. Now I'm going to go ahead and maybe add something that allows us to differentiate between tile colors. So let's first go to our board and add a public void server set tile owner player value. Okay, I'm going to decorate it with the server RPC attribute and say require ownership equals to false. And inside this, I'm going to go ahead and call observers set tile owner, and I'm going to pass it the value that we sent to the server RPC. Now let's go down here and declare the observers RPC and have a private void observers set tile owner player value. Okay, and simply we need to pass here the index of the tile that we would like to set the owner of. So int tile index, and we need to pass it here, so int tile index as well. Let's pass it here, and we're good to go. Now here I'm going to simply go ahead and say tile index dot owning player equals player. Let's rename this to value. Okay, this code here will work, no problem, but in order to synchronize the correct owner when a player joins in later, okay, so for example you can start the game and have 2 players, and then suddenly a 3rd player joins, it won't know which tile is owned by who. In order to fix this, we can go to our observers RPC here and say buffer last equals to true, meaning that the last values sent to this RPC are going to be buffered, and this RPC is going to be called, so the correct values will be set, okay, even for people who join the game later. Now I'm going to go ahead and inside my tile here, I'm going to add a very simple and crude color switching mechanic. So I'm going to say serialize field, private mesh renderer, and inside the late update method, I'm going to say if owning player is equal to null, simply exit the method. Otherwise, I'm going to go ahead and say color equals game manager dot instance dot index of dot players dot index of owning player switch. So what I'm writing right here is what's called a switch expression. It allows you to do some inline checks and return the values depending on the value of this value here, variable here, or result expression here, okay? So for example, I'm going to say if the player index is 0, then simply the color is going to be red. If the index is 1, then the color is going to be green. If it's 2, it's going to be blue. And if 3 is going to be yellow, maybe. okay? And otherwise, we're going to return color.white, okay? After we do this, I'm going to go ahead and say mesh render dot color, sorry, dot material dot color equals color. And we can even further inline this by moving the switch expression instead of being into a variable to be right here, as you can see. Much clearer and much more concise code. Now we're simply going to go ahead and say if the owner, let's actually store the default color here, so private color defaults color. All right, we're going to set it when we start the game, so we're going to say default color equals mesh render dot shared material dot color. Okay, and I'm going to go ahead and say if the owner is null, then simply assign the default color to the materials, to material dot color equals default color. All right, let's go to the main view and add a button that allows us to purchase tiles. So serialized field, private button, purchase tile button. So here, purchase tile button dot onClick dot add listener. And what we're going to do is simply grab the current pawn's position. So int pawn position equals player dot instance dot controlled pawn dot current position. All right, and we're going to go ahead and say if board dot instance dot tiles at the pawn position dot owner equals to null. Okay, we're going to say board dot instance dot set tile owner. We're going to call the server method and pass it the pawn position, and then supply the player dot instance as the value parameter. Okay, now let's go ahead and enter the editor here, select our tile, assign the mesh renderer. Okay, and I'm going to go back here. I'm going to go ahead and go to scene number 2, select our canvas, go to our main view, and duplicate the move button to actually create the purchase tile button. Move it all the way to the top, change the anchor to -10. Oh, yeah, need to change this to -10. Change the text to be purchase tile, and assign the correct reference here. Then go to scene number 1, and I'm pretty sure we can go ahead and Control B to build the game now. All right, I'm going to enter play mode here. I'm going to host and the player, and I'm actually going to, you know what? No, let's go ahead and start the game first here. Then we're going to start. All right, now I'm going to first purchase the tile I'm currently standing on. So as you can see, it did switch the color to red, and it's synchronized between the two clients. Of course, you can have a camera that focuses on the entire board. You know what? Let's actually do this real quick so it doesn't look so ugly. Okay, let's center this baby. Let's rotate it 90 degrees. Let's move it up more. Okay, like this. So 25. Let's change this to a physical camera and set the gate fit to vertical. Then set the field of view to 60 and save. All right. change the clipping, and change the far clipping plane. And let's go ahead and save. Go to scene number 1 and click Control B to build. All right, let's enter play mode. And let's host here, connect our console, and connect from the editor. And let's press ready on both, then click start. Okay, now I'm going to purchase the tile I'm standing on, which as you can see is synchronized correctly. I'm going to move forward. Then I'm going to go to my client. I'm going to purchase this tile. Oh, and nothing happens. Interesting. What could be causing this? So let's see, tile number 2. No order is being assigned. Interesting. So let's actually exit the play mode here. Let's go ahead and check real quick. We are sending the correct values and everything, so this could be a little issue, you know, that it's not sending to everyone, which is weird. Or maybe this check right here is failing somehow. So let's go ahead and remove it just for the sake of testing. Let's Control B. All right, we're going to do a quick build. Enter play mode here. Host the game. Connect the console. And I'm going to connect the editor as well. Now I'm going to start. I'm going to purchase this tile. Okay, it works on the host. Let's move forward. Let's purchase a tile here. Oh, so yeah, this is because we are not correctly synchronizing the current position. And this is because the current position is not being set. Is not getting synchronized correctly is what I mean. So let's see. Why is it not getting set actually? Let's go ahead and exit here. Save and let's clear this. Let's see. Current position is a sync var indeed, which is right. And we have the server move, which is a server RPC indeed, yes. And when the tree completes, we set all these to this to false, and then we increment the current position. So this is a little weird, all right, but let's go ahead and see here in our player script here. Let's read the main view. So it's retrieving the correct value, but it's not transferring the So let's see. Okay, we might be doing something wrong, but I doubt it really. So let's go ahead and do a different approach to synchronizing this value here. I'm going to make it public, but instead of using a sync var, I'm going to go ahead and say public void observers set current position. I'm going to supply an integer, and I'm going to call it value. Inside of it, I'm going to say current position equals value, add the observer RPC and buffer the last value. And here I'm going to set, say observers set current position to current position plus the step count. All right. And let's actually return the check here, so we cannot purchase other players' tiles. So board instance tiles at the pawn position owning player equals to null. Then purchase the tile. Okay. Let's go back to the editor. Save. Do a quick build. All right. I'm going to enter play mode here. I'm going to connect my console. Okay, I'm going to go to the game mode here, game view here, host here, then connect here, and ready on both. Then I'm going to start the game. The first thing I'm going to do is purchase this tile. Okay, it's going to move forward. Then I'm going to go to this client, move forward. All right, so I'm going to just move here again, not purchase anything. Then I'm going to purchase a tile here, and as you can see, it synchronizes correctly. Maybe we were doing something wrong with the sync bars, but yeah, it's working fine now. And as you can see, players can purchase tiles. Ooh. Oh yeah, because we actually already own this tile. So yeah, let's move forward. Let's purchase this tile, and as you can see, it synchronizes correctly. So that's actually all the basic mechanics you need for a simple board game, like the one we created here. Of course, this is a foundation. You can extend it in any way you would like to. You can add currency, you can add more players, you can add all kinds of crazy stuff using all the basic features included in Fish networking. And actually, the entirety of this stream, we used only sync vars, we used RPCs, and we used network behaviors. We didn't use any special or complex stuff like broadcasts, even though they are quite easy. Or we didn't use any custom plugins except for Dotween, just for the sake of convenience and ease of functioning. So yeah, also we used sync lists, as you can see here. And we learned about a couple of tricks like the property trick here and the server attribute here, which are both very cool and very useful. So yeah, that's pretty much it for our stream today. Before I go ahead and exit the stream and end the stream, if anyone has any questions, we still have 5 people in the chat, so go ahead and ask it. I'm going to be waiting a little bit for any questions to pop up, as I mentioned before in the stream. So if you have anything, go ahead and make sure to ask it. Okay. Any questions, everybody? Okay, it seems that we have no questions so far. Just going to wait for an extra minute because I know that somebody could be typing a message as I end the stream. All right, so it seems that no one is asking anything. So I hope you guys enjoyed the stream. If you did, please consider supporting me over at Ko-fi. You have a link in the bottom left corner of the screen. Your donations really help make the streams, and they help me personally to create better and more useful stuff for you guys to watch. So thank you so much for watching. Thank you so much for sticking till the end, and I will see you in the next